All right, in this video, I'm going to go over zeros and their multiplicities. Now, remember what a zero is. It is where a function crosses the x-axis or touches it, as we'll soon find out. But first of all, we need to understand what multiplicity is. So, another way of writing out this function, just to give you an idea of what multiplicity is, quantity x plus 3, quantity x plus 3, there's an understood 1 there, right? So there's just 1. But x minus 2 is squared. So there's 2 of them. Yes. And x plus 1 is cubed. So there's 3 of them, if I can write things correctly. And that's what we're talking about. We're talking about how many times a specific factor appears in a function once it's all factored out into binomials. Right? So this one appears 3 times because it's being cubed. So the multiplicity of -1 is 3. And the multiplicity of 2 is 2. Multiplicity of -3 is 1. Got it? It only appears once. And I found these by setting them equal to 0. I just did a little quick mental math, right? Add 2 to both sides. Subtract 1 from both sides. Right? Same with x plus 3. So, but wait, I thought the largest exponent was the degree. No, degree is a different thing. Degree is what you see when all of this is FOILed out. You know, if you were to actually go and FOIL all of this out, first, outside, inside, last, for all of these, what would your degree be? Your highest exponent? It would be 6. How do I know that without actually multiplying them all out? Well, because we know this is going to be multiplied 3 times, so there's going to be an x cubed there. This is going to be multiplied twice, so that's going to be x squared times x cubed eventually, which will be x to the 5th, right? And then one more, so x to the 6th. Because when you multiply exponents, you add them together. So you could take a shortcut and just add 1 plus 2 plus 3, and you get 6 is the degree. Okay? That is the relationship between degree and multiplicity. Now, why do we need to know degree? Well, so we can do a rough sketch of the graph. Not an exact sketch of the graph, but a rough sketch of the graph. What does the degree tell you? It tells you the end behavior, right? Since it's an even number, and this is a positive function, the arrows are going to be pointed up on both the right side and the left side. It's good to know. Okay. What about our zeros? Let's make a list of our zeros. X equals -3, x equals -1, and x equals 2. I put those in order from least to greatest, right? That's just how I like to do things. So, the first time it crosses the x-axis when going from left to right is at -3. Okay. But how does it cross the x-axis? Well, they tell you how it does that with the multiplicity. Because it's a 1, it will just go straight through. Okay. Now, the next time we cross the x-axis is at -1. Okay. -1 has a multiplicity of 3. What does that mean? It's an odd multiplicity, so it is going to go straight through, just like the 1, but it's going to get a little steep first. It's not just going to go right through it. It's going to do a little fanciness. Going to get kind of close and do that. If you recall the graph of x cubed, it does this. It gets kind of close, and then it crosses, and then it speeds up again, and it does a little fancy thing. Now, what's the next one? 2. 1, 2, crosses at 2. Now, that one is multiplicity of 2. What does that tell us? It tells us that it's going to go touch and then keep going. It's not going to go through. Only the odd multiplicities go through. The even ones just touch. All right? Stay tuned for part 2. All right, here's another example. What happens if we go beyond cubed? What if it's to the 4th power? Well, let's figure it out. First of all, let's figure out what our degree is. Degree is what? 4 plus 5 is 9 plus 6 is 15. Why do we need to know that? Because it's odd. It's an odd number, which means our end behavior of our graph will look something like this, right? But there's a negative out in front, so it's negative odd, which means we're going to start off going up and then going down to the right. Up to the left, down to the right. Just like when you're graphing a line, right? If the slope is negative, it's going down to the right. Okay, now what? Well, now we list our zeros. You can do that pretty fast now, right? X equals -2, right? X plus 2 equals 0. X equals +1. Sensing a trend here, +4. It's kind of the opposite of what the factor is, right? Okay, what's the multiplicity of -2? 4. Multiplicity of +1 is 5, and the multiplicity, let's put a mult here, multiplicity of +4 is 6. Now, I'm doing this to demonstrate what it looks like when, those numbers get bigger. What really matters is what's odd and even, but the graph gets flatter the larger these numbers are, right? Let me show you just how. So we have a 0 at -2, 1, 2. 0 at +1, and a 0 at +4, right? Going up to the left, so drew too soon, okay? This is where that 4 comes into play. It's not just going to go and touch it like a parabola. It's going to flatten out a bit first and then go up real fast. Okay? That's what it means. It just touches it and then it goes up a little further. That's what we mean by flattening out. Now, what's the next one? Multiplicity of 5 at x equals 1. Same thing. We're going to flatten out, slowly approach the 1, cross it, and then dip. Just like with cubed, except maybe we dip a little sooner than that. The graph is very flat right there. There's still a little jump, but it's very flat there. Now, x equals 4, multiplicity of 6. It's going to be even flatter than the multiplicity of 4. It's just touch and go. There, just like that. Got it? All right, now I'm going to do other examples where we look at the graph and we figure out what the factors of the function are. All right, now we're going to work backwards. We're going to look at the graph and figure out what the factors in our function are. So, what are the zeros? 1, 2, 3, 4, negative 4, negative 1, 1, 2, 3, 4, and positive 4. Okay. They give us the degree. They should do that so that you know, hey, there are 3 points, the degree is 6, it's probably going to be 1, 2 plus 3. 1 plus 2 plus 3 equals 6, right? So we just need to figure out which one has the multiplicity of 1, which one has a multiplicity of 2, which one has a multiplicity of 3. So how do we write the 0, negative 4? Write it x plus 4, right? Because it's x plus 4 equals 0. We just kind of work backwards. We had our answer from the beginning and we made it into a binomial for our function, right? That's how I got there. Same thing for negative 1. It's now x plus 1 in the function. And for positive 4, that's going to be x minus 4. See, now you might have, if you mix this up, you might have still gotten the answer right, but you got to make sure that one's correct. You might have an x minus 1 there, which is not right. X minus 1 crosses the x-axis at positive 1. Okay. So which one has which multiplicity? Well, this one just bounces off, so we can assume that negative 4 has the even numbered multiplicity, so that would be 2, right? Because it has to be 1 plus 2 plus 3 to be 6. So we have 3 different parts. I suppose it could be 1 plus 1 plus 4, but that doesn't seem to be the case here, does it? Right? Because this just goes straight through, and it doesn't flatten out first, it just goes straight through. So negative 1 multiplicity would be positive 1, or you could just leave it blank. It's an understood 1 there. What about positive 4? Yeah, it kind of flattens out, doesn't it? And then goes through and then takes off after it stays flat a little longer. So that would be our multiplicity of 3. And there's your answer. All right. One more example and we're done. All right, last one. Let's see what we got here. 1, 2, 3, 4, 5. So 0's at 5 and, or negative 5, negative 1 and 1, 2, 3, positive 3. Okay. So that means we have factors x plus 5, x plus 1, and x minus 3. All right? They give us the total degree. They give us the degree, which is the total multiplicity. So we need to figure out which ones have which multiplicity, which zeros have which multiplicity. So start with negative 5. Kind of flattens out and then goes through, so it's odd, but it's bigger than 1, so let's go with 3. All right, we got 6 more degrees to go. Just touches, right, and then keeps going. It doesn't really flatten out, so negative 1, multiplicity of 2. Now, positive 3 kind of flattens out, and I wish I could draw better, and stays flat and keeps going, right? So it would be even, because it just touches, but it would be bigger than 2, so let's go with 4. Does that up to 9? Add up to 9. 3 plus 2 is 5, plus 4 is 9. And it's odd, so the end behavior, one goes up, one goes down, and it's positive because it's going up as we go from the left to the right. And there's your answer. Thank you for watching.